Hi everyone, this is the video on locus and constructions, again using the plan.in worksheet, Peter plan.in on locus and constructions as requested by Crazy Lad, whoever Crazy Lad is. Okay, the first question over here, it says draw the locus of all points which are equidistant from point C and D. Before we go ahead and solve this, quick description of what locus is. Loci is a set of points. Sorry, a locus is a set of points that follow a particular rule. In this case, the locus of all points which are equidistant from the 2 points C and D. So that would be anything that is the same distance away from C and D. And to do this, what I'm going to do is I'm going to need a compass, a pencil, right? And C and D are 2 points, as shown in the diagram. So I'm going to construct the perpendicular bisector for this. So to do that, I am going to place the metal tip at D, and the width of my compass should be greater than halfway between C and D. Yep, that's greater than halfway. I'm going to draw an arc here, an arc top and below, or you can just draw one big fat arc there, and you do the same thing from the other side. Okay, now this is the perpendicular bisector. So if CD was a straight line, and if I were to draw a line to join them up, the perpendicular bisector would split that line CD into 2 equal parts, and all the points, and it would make a 90-degree angle. I don't need to do that, I need to do this, sorry. I join the points. Okay, now you see the line which I have drawn over here. Anything over here, any point on this line is the same, exactly the same distance away from C as it is from D, and you can measure it. Suppose I choose a point here. It is about 5 centimeters away. It's just over 5 centimeters away. There you go. That's the locus of all points between 2 points, equidistant from 2 points. Now here, draw the locus of all points that are exactly 3 centimeters away from the line EF. To do that, again, need a compass, ruler. You see, I need to draw the locus of all points that are 3 centimeters away from this line. So in order to do that, again, I need to align my protractor 3 centimeters. Okay, there, not my protractor, my compass. I'm going to measure 3 centimeters on there, measure 3 centimeters. I'm gonna draw an arc from the point F, a semicircle almost, not almost, exactly a semicircle. So, and the radius is 3 centimeters. And I'm going to do the same thing from E, which is draw a semicircle, struggling with this one. There we go, manage that. And what I'm going to do is I'm going to join the 2 ends of the 2 semicircles up. It's a bit fiddly this, oops. Looks like a cucumber or a racetrack. I think it's Daytona. Okay, and just to double check, it should be about 3 centimeters, and it should be also just about 3 centimeters. With the construction questions, if you're up to 2 millimeters away, they'll still be able to give you most of the marks, not all of them. Anyway, the next one is draw the locus of all points which are equidistant from 2 lines, x, y, and y, z. Now, x, y, and y, z are 2 lines. They meet at x, they form an angle. So, the locus of all points that are equidistant from x, y, and y, z is the angle bisector. And to construct the angle bisector, you need to place the metal tip of your compass at the vertex of your angle, which is X. Draw an arc, and from each place where the arc intersects the line, what you need to do is draw another arc from there, draw another arc from there. That's your angle bisected, and draw a line from the vertex all the way through. Okay, but you have to go, if it was an angle bisector, I would not draw this bit here, but because it's the locus of all points that are equidistant, I have to carry on both sides. Okay, so, and any point on this line is the same distance away from xy as it is from xz. Right, the next question is there. I'm going to kind of rush through this because there's not much time. There we go. The map shows a golf course. A golfer has to hit a ball so that the path between AB, which is this, and CD, which is this, is a straight line, and is always the same distance as it is from A as from B. So that means these are 2 points, the same distance between them, perpendicular bisector. So what I'm going to do is I'm going to go around and draw the perpendicular bisector, which is more than halfway, arc, arc, same thing here, arc, arc. Where's that ruler gone? So I'm going to make sure by touching these points that I go through the right way and draw a line. Okay, so that's a straight line. Golfer has to hit the ball so that the path between AB and CD is a straight line. It is, and is always the same distance from A as it is from B. Every point on this line is the same distance away from A as it is from B on the map. Okay, that's it. Done. Next, ABC is a triangle. Shade the region in the triangle which is both less than 4 centimeters from B. Now B is a point, so the locus, this is region, so the locus of all points that are 4 centimeters away from a point is a circle. So I'm going to measure 4 centimeters on there, and I'm going to go to B. I'm going to draw a circle around. Those are all the points. That's the locus, right? That is 4 centimeters. All these points over here on the circle are exactly 4 centimeters away from B. But it says shade the region inside the triangle which is both less than 4 centimeters. Since it is the region which is less than 4 centimeters, it's anything that is inside the circle from point B. That's the first condition. Let's find out the second condition before we start shading. And closer to the line AC than it is to AB. AC to AB. So what we need to do is something that goes exactly halfway, which is the angle bisector for angle A. So I'm going to just draw an arc here. Draw one arc. Draw the next one. Okay, and the angle bisector will look like that. You can always double check with the protractor whether you've got the angle bisector right by measuring the angle. So the angle itself is 65, 66, about 68. So this angle should be 34, and it is 34. So there we go. It says it has to be less than 4 centimeters, which should be within the circle, and closer to the line AC, so it should be on this side and this side. So I'm gonna shade in. 1 second. yeah, I'm going to shade in this bit because it fulfills both the conditions. It's closer to AC than AB, and it's 4 centimeters. It's within 4 centimeters of B. All right, number 5. Right, question number 5. Here is a map. The map shows 2 towns, Knutsford and Macclesfield. Alright, and it says there's a scale here. 1 centimeter represents 10 kilometers. Company is going to build a glass house, and it will be less than 30 kilometers. So that I know is going to be 30 divided by 10, which is 3 centimeters. From Knutsford. And have to measure 3 centimeters. Time is of the utmost importance. 3 centimeters away from Knutsford. Quickly draw a nice neat circle. Radius 3 centimeters from Knutsford. Okay, and less than 50 kilometers from Macclesfield. So that's going to be 50 divided by 10, which is 5 centimeters. So 5 centimeters away. From Macclesfield, draw a circle. 5. Can't draw a complete circle because the rest of it is out of the diagram. Shade the region on the map where the company can build the glass house. So it'll be the overlap, which is here. Just put some more lines there. That's it, done. Number 6. The diagram represents a solid made from 5 identical cubes. On the grid below, draw the view of the solid from the direction A. So you can see 1, 2, 3 squares and 1 up. One, two, three, 2 up, I should say. Like an L shape. If I was standing directly in front. But I would have these 2 protruding out a bit, so that's why I've left these 2 as one block, because they're protruding out. And yeah, there we go. Ta-da, 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 ta-da. How many more questions we have? Whoa, there's a lot. There's 18. So I'm going to try and rush through this because I'm on number 7. It's already 13 minutes in. Here is the plan and the front elevation of a solid shape on the grid. The plan is the view from the top, directly from the top. Front elevation is the view from the front. You know it's a trapezium kind of shape. On the side, on the grid below, draw the side elevation. Okay, the side elevation is going to be like a square, 2 by 2. Because this is 2, we know the height is 2. So we can only see it from the side. Can't see anything else. 2 by 2. In the space below, draw a sketch of the solid shape. So they want the 3D version. 2. Is it a centimeter? So what I'm going to do, it's 2 centimeters wide. Then I measure 2 centimeters down. Make a point. about 4 centimeters here. Join it up. Okay, and just there. Try and make sure these two lines are parallel. These two are parallel, and here we go. And that's a rough 3D sketch. It does say sketch, it doesn't have to be super accurate. You have to use a ruler. Should have used a pencil. In the exam, use a pencil. Okay. In the space below, use a ruler and compasses to construct an equilateral triangle with sides of length 6 centimeters. So this line here is 6 centimeters. So the first thing I'm going to do is measure 6 centimeters. Whoa, it's over there. Okay, so I go to one end of the diagram, of the line segment I should say, and draw an arc, and I go to the other end of the line segment and draw another arc. Because it's an equilateral triangle, all three sides are the same length, and draw that line through, and draw that line through as well from here. And as it's an equilateral triangle, all the angles should be 60 degrees, so I can quickly double check that. This one's 60. This one is 60. The third one has to be 60, 60, 60, 60, 180. There we go, goodbye. Next. Now this one's a bit rushed, but I am trying to get as many questions done in a very, very short amount of space of time. Okay, this question we have to draw the actual shape. So we start off by drawing the baseline, which is 6 centimeters. Okay, and that'll be X. Then we need to measure an angle of 110 degrees at W. Make sure that the center of the protractor is at the point. The baselines are aligned. Because the line is on the right hand side of the point, I'll start from the 0 on the right hand side. 110 is there. Make a point. Need to make sure that I'm going to draw a long line. I'm going to measure it. It should be 110. Inshallah. 110. Okay. Then I'm going to take my compass. Make sure its width is 4 centimeters. And I'm going to draw an arc. So that's when it's 4 centimeters. So that's the point Z. Okay. Then I have to measure 70 degrees from here. 70 degrees. And draw the line again. Measure 5 centimeters. Let's write 4, 6, that's 5. And you just have to join these two points, and it's going to be there to there. Join it, and that's Y. zy, wx, zy. Done. Oh, I didn't write down the angles. 110 degrees and 70. Okay, next. On the... Oh, are you kidding me? On the grid below, draw an isosceles triangle. I can't believe this question. I can't get my hand through. Oh, there we go. 1, 2, 3, 4. So the reason I chose 4 is in an isosceles triangle, this is the base, right? So the two base angles are equal and two sides are equal. So the angle at the top, its vertex is going to be directly above the midpoint of the side at the bottom. There you go. On the grid, draw a rectangle with an area of 20 centimeters squared. So I can say 4 times 5, 4 by 5. So wait, are there 5? 1, 2, 3, 4. Yeah, that should fit. 1, 2, 3, 4. 1, 2, 3, 4, 5. Don't mind me. You can get along. And there we go. Oops, that's a mess up. There. Done. I'm not going to do question 11, it's ridiculous. Perpendicular bisector of AB. I'll show you this. Again, it's like question 1. We need to make sure that the width is more than halfway. And you can draw an arc and draw an arc. Or you can just draw a full arc. And then same thing from the other one. Make sure the width is more than halfway. And that's what I meant by the perpendicular bisector. Bisects it into two equal parts. And if you measure this angle, it is a 90-degree angle. Perpendicular bisector. Right, next. Quickly, 6 more. I won't do all of them. I'll only do the ones which are tricky. Okay. Number 13, you have to construct an angle. Let me just change the camera angle. Zoom in a bit. Yeah. So use your ruler and compass to construct an angle of 30 degrees. At T is over here. So in order to construct this, what I need to do is draw an arc. Now you see, if I was to draw like a semicircle, it's 180 degrees, and without changing the radius, if I was to if I was to go to that point over there where the arc touches the line and draw an arc here, this angle is 60. If I draw a line from T through there, it's going to be 60. If I do a second arc over here, that angle will be 120. But the question is asking me for 60 degrees. So I draw this, that would be 60. So half of 60 is 30. So I'm going to bisect the 60 degree angle. So I'm going to draw an arc from there. I'm going to go to that point and draw an arc. And just draw a line through. And I'm going to measure it. And hopefully it should be 30 degrees, apparently. Right, I need to hurry up because I'm running out of time. I need to do something on bearings as well. If I get the time. Did I mess up? I did. It's exactly 10. Oh, sorry. I've gone off by 3 degrees. So I need to redo this. So I'm gonna redo the question because I've done it in pen. Now I'm gonna have to redraw it. It's 6.7 centimeters. So let me just draw this again. Last thing I wanted. when I'm limited for time. But anyway, that's the line T. What I need to do, try and be more accurate this time, is draw an arc like a semicircle. Okay, so make sure compass is at the point over there. That angle over there would be 60. I'm going to draw an arc from here, bisect the angle of 60. There we go again, same thing. Make sure that I join the points. There we go. It's literally the same process, I just went slightly off. This one's exactly, is it exactly 30? Yep, it's exactly 30. Sorry about that, but anyway, like to be accurate. Use a ruler and compasses to answer this question. Point P is the same distance from AB as it is from AD. AB as it is from AD. Angle bisector. So do that. Draw an arc. What happened there? Right, so sorry about that. Phone call, important. Okay, so I draw an arc. Whoa. And from there, the intersection of the arc and the line, I'm going to draw one arc here. I'm going to go to the other side. I'm going to draw a second arc there. Woohoo. And I'm going to draw a line. It's going to take a little bit of time. From A, it has to go through the intersection. So go all the way through. You shaky hands. Okay. And you can measure with the protractor if you've got this right. Again, I'm using a pen here so that it can be highlighted, but in the exam, use a pencil please. Otherwise you'll have a situation where you might mess up like I did in the other question there. So this is 98, I'm getting 50. So I'm 2 degrees off already. But it's within the region. And exactly 6 centimeters away from C. It's within the error boundaries of that. Woohoo. So that's 6 centimeters away from C. Okay. Use a ruler and compasses to answer this question. Point P, the same distance. Okay, so where the circle touches the line, that's point P. There we go. 3 marks for that. Oops. Yeah. Okay, we have 15, 16, 15 and 16, 17 and 18. Okay. Question number 15. Here is a map. The position of a ship S is marked on the map. Good for the ship. The scale 1 centimeter is 100 meters. Very important. C is the point on the coast. Ship must not sail closer 500 meters. So you do 500 divide by 100, which is 5 centimeters. Okay, so I need to draw ruler, line 5 centimeters, 5 from C. Is it exactly 5? Let me measure it. Okay. So that's 5 centimeters away from C. Okay, the ship sails on a bearing of 37 degrees. A bearing is an angle clockwise from the north. So I'm going to place my protractor over there. Okay, I'm going to start from the 0 on the outside. 35 is there, 36, 37. Let me mark this under a very fine point over there, 36, 37. That point there. Okay. The ship sails on the bearing of 37 degrees. Will the ship sail closer than 500 meters to the point C? So for the ship to sail closer, let me measure my angle. Whoa! It should be exactly 37. Oh, I've measured the wrong angle. Sorry. 37 is over there. So, not this line. I'll cross that off. 37. Will it ship? And messed up over there. Will it ship closer to 500 meters? Of course it would, because it comes inside the circle. Yes. You must explain your answer. Since the angle representing the ship's journey enters the region that is 500 meters away from C. There we go. Right. 16. The diagram shows a garden in the shape of a rectangle. Scale is 1 centimeter, 2 meters. He plants a tree in the garden. The tree must be no more than 3 meters from the patio. Okay. So the patio is like a rectangle, so you can measure 3 centimeters. No, 1 centimeter represents 3 meters. So 3 divided by 2, which is 1.5 centimeters over here. So you have to have 1.5 centimeters. Can you see that? Yeah. 1.5 centimeters. And I'm going to draw a line which hopefully is parallel. Okay.